Good morning, good afternoon, and good evening, everyone. This is Carmelin Baricuatro helping you with your math lessons. In this video, we're going to focus on how to find the asymptotes of a rational function, which is the vertical asymptote, the horizontal asymptote, and if needed, we will also going to find the slant or oblique asymptote. So, let's start! So we have here is the example number 1, which is the f of x is equals to 2x over x plus 3. So we will going to find the vertical asymptote first. To find the vertical asymptote, we will going to equate our denominator into 0. So let me show you. Here, this is our numerator and this is our denominator. So we were going to equate our denominator into 0. So x plus 3 is equals to 0. To solve for this, we're going to transpose our positive 3 here. So, bring down the x. Once a number crosses the equal sign, its sign will automatically change. So, the positive 3 will become negative 3. So, here. This is our vertical asymptote. Now, so we're going to proceed to finding the horizontal asymptote. So, in finding the horizontal asymptote, we're going to base on the exponent or the degree of our numerator and denominator. So, meaning, we were going to look at their exponent. And we have 3 statements here. I'm just going to call it statement because I forgot what it's called. So, their statement. The first statement says, if the degree of our numerator is lesser than the degree of our denominator, then our horizontal asymptote is 0. And the second statement says that if the degree of our numerator is greater than the degree of our denominator, then we have no horizontal asymptote. And the third statement says that if the degree of our numerator is equal to or the same to the degree of our denominator, then simply we were just going to get the leading coefficient of our numerator and the denominator. So in terms of our first example, we can see here that the degree of our numerator and the degree of our denominator is the same. So we're going to base on the statement number 3. So, as said here, we're going to get the leading coefficient with the numerator and denominator. So, here, the leading coefficient in the numerator is 2. So, we're going to put 2 here. And always remember that in every variable, there is an invisible 1 beside it. So, here, our leading coefficient is 1. Simplify this. 2 divided by 1 is equals to 2. So, this is our horizontal asymptote. Now, if you still don't get it, I have another example here, which is that f of x is equals to 4x over 2x plus 1. So, this is our second example. Let's put this number here. Now, again, to get the vertical asymptote, we're going to equate our denominator into 0. So, 2x plus 1 is equals to 0. Transpose the 1 here, and the positive 1 will become negative 1. So, bring down the 2x. Now, we're going to erase that. Sorry. Bring down the 2x. And here we have negative 1. Now, we will going to eliminate the 2 by dividing both sides by 2. So, divided by 2, divided by 2. 2x divided by 2, we're going to cancel 2. So, bring down x is equals to negative 1 over 2. We cannot simplify it because simply we cannot. Yes, we cannot. So, this is our vertical asymptote. Now, again, proceed in finding the horizontal asymptote. remember the three statement that I told you just now? Okay, so here in our example, again, we have the degree of our denominator and the degree of our numerator is the same. See? So, again, we're going to base on the statement number 3. We're going to get the leading coefficient. So, here is simple. 4. Leading coefficient here is 4. And the leading coefficient of our denominator is 2. Now, we're going to simplify it. We're going to simplify it. 4 divided by 2 is equals to 2. Now, this is our horizontal asymptote. Now, when can we say that there is a slant or oblique asymptote? We can say that there is a slant or oblique asymptote when there is no horizontal asymptote. Remember the 3 statement that I told you in finding the horizontal asymptote? The second statement says that if the degree of our numerator is greater than the degree of our denominator, then we have no horizontal asymptote. Pardon me. And once we have no horizontal asymptote, that is the right time to solve for the oblique or slant asymptote. So, alright, in addition, we cannot solve for the horizontal asymptote and the oblique asymptote at the same time. In every example, we will be able just to solve for one of them, whether the horizontal asymptote or the slant asymptote. Okay? Okay. So, a tutorial video will be posted here on this YouTube account sooner about how to solve for the oblique or slant asymptote. So, you don't need to worry. That's all for today. Thank you and good morning, good evening, and good afternoon, everyone. I hope you learned something from this video, and if you still need clarifications, you can message this YouTube account or comment down below. Bye-bye!